Page 3 of normal distribution. Remember how on last page they always asked us to identify probabilities that were exactly on the standard deviation lines? So we were able to use 68, 95, 99. Well, on the exam, they're going to ask you random intervals that are not exactly on the standard deviation line, and then you're going to use the calculator to do those. Actually, it's probably even easier. Okay, so how do you do that? We're going to use the second distribution button, and then we will choose the normal CDF option, and then we're going to put in the left interval number, we're going to put the right interval number, and then we're going to put the mean and the standard deviation. And then we hit enter on top of paste, and then we hit enter one more time. So I'm going to show you how to do that several times, so don't worry, it's easy. The only tricky thing maybe is putting in the number negative infinity or positive infinity. Here's an example of putting in negative infinity. We do that by typing the little negative button, which is at the bottom of the calculator right there, not the minus sign, the negative button. And then you type in the EE button, which is blue second, and then you type the comma, which has the double E over it. When it types the double E, it doesn't actually put two E's, it puts a little single capital E, and then you type 99. And so this represents negative infinity. So of course, positive infinity, you just, I'm sorry, I forgot to type 1 EE99. So if it's positive infinity, of course, you just don't type the negative sign, and that's it. Okay, so let's do some examples. Number 1. Capital X is a random variable that is distributed normally with mean 70 and standard deviation 4. Find the probability, P is probability, that the random variable is between 70 and 74, inclusive. Now remember, for a normal distribution, it doesn't matter if it's inclusive or not, right? It could have been less than. It's same answer. Okay, so they say here that the mean is 70 and the standard deviation is 4. So let's do the picture first. 70 in the middle, 74 and 66 on the sides, 78 and 62 on the besides those, and then finally we'll have 82 and 58. Okay. And what we're going to do is we're going to color in the section of X that's between 70 and 74. That would be between these two. Okay, and even though we could say that that's already 34%, let's use a calculator to figure that out and see what the calculator says. We know that that section is 34% from 68, 95, 99. So we're going to press second distribution, and then we're going to go to norm CDF, which is what we're going to use most of the time. And we're going to put 70 for the left interval and 74 for the right interval. So we'll put 70 and 74. And then, of course, the mean is 70 and the standard deviation is 4. And then we hit enter and enter again. 0.34134. Okay, so I'm going to put 5 sig figs as a habit just for normal distribution, because you'll see that later sometimes it comes in handy to have a lot of sig figs. So we're going to put 5 sig figs, 34134 for the answer for this one. Okay, and then let's go to the next one. The next one says between 68 and 72. So first I'm just going to label the bottom at least until there, and then 68 to 70. Okay, we're already starting to get some that are in between. So 68 is actually in between standard deviation lines. 72 is actually in between standard deviation lines. So now we have to use the calculator. There's no other way to do it. Second distribution, norm CDF, and we're going to put in 68 and 72. And then 70 and 4 are already typed in, and we just hit enter twice. 0.38292. 0.38292. Okay. And last of all, this is the tricky one. So X is less than 65. So first we're just going to, again, do the x-axis with the standard deviation intervals correctly, and then we're going to mark 65 on here. 65 would be maybe about there, right? 65. and then we're going to say less than 65, so it would be to the left of 65. So it's that interval right there. It goes on to theoretically negative infinity. So we're going to put negative infinity as the left boundary and 65 as the right boundary. So let's do that second distribution, norm CDF, and we're going to put negative 1 second EE 99, and the right boundary is 65, and then the mean is 70, and the standard deviation is 4. 0.10565. 0.10565. Okay, so that is the answer for the probability that it is less than 65. All right, what do you think of this notation? It's all right, right? Probability that the random variable is less than 65. That's all it says. All right, let's do some word problems. A machine produces metal bolts. The lengths of these bolts have a normal distribution with mean of 19.8 and standard deviation of 0.3. If a bolt is selected at random from the machine, find the probability that we'll have a length between 19.7 and 20. Okay, we can already kind of see what we're going to fill into norm CDF, right? But just to see what our answer is going to look like roughly, I am going to put an x-axis here. The mean is going to be 19.8 and 19.8 centimeters, and the standard deviation is 0.3 centimeters. So I'm just going to add and subtract 0.3 to get other values here. If I add 0.3 to 19.8, that would give me 20.1. If I add 0.3 to that, I would get 20.4. If I add 0.3 to that, it would be 20.7. If I subtract 0.3 from that, it would be 19.5. If I subtract 0.3 from that, it would be 19.2. And if I subtract 0.3 from that, it would be 18.9. Okay, and now I'm going to check to see what is the probability that we'll have a length between 19.7 and 20. So 19.7 would be about here, and 20 would be about here. So this would be 19.7, and this would be 20. There's my interval right there. Looks like it might be about 30%, right? Whenever you draw these intervals, you can kind of get an idea of how much of the 100% it would be, and I say that would be about 30%, and then I'm just going to use that to make sure that the calculator is giving me about the right answer. So I'm going to put 19.7 and 20 as the right boundary, the upper, and then the mean is going to be 19.8, and the standard deviation is going to be 0.3, right? 0.3. And then I hit enter twice, and it's 0.37807. 0.37807. Okay. Yeah, that's about 30%. Okay, sounds reasonable. Eels are washed onto a beach after a storm. Their lengths have a normal distribution with a mean of 41 and a variance of 11. Okay, so this is a little bit tricky because they're giving us variance instead of standard deviation. Notice that variance has a units of centimeters squared. So variance, remember, the variance is actually equal to sigma squared. And when we want to do normal distribution with the calculator, we have to have sigma, not sigma squared. So in order to get sigma from the variance, we do need to square root it. So the square root of 11, that would be the sigma value. So let's use the calculator to find out what is the square root of 11 first of all. 3.32. Okay, so the sigma value is 3.32, the mean is 41. So let's write that here. 41 plus 3.32 would be 44.32. If I subtract 3.32 from 41, that would be about 37.67. 0.68 or something like that. Okay. If an eel is randomly selected, find the probability that it is at least 50 centimeters long. 50 centimeters long looks like it would be pretty, far over there, right? 50 centimeters long. And I want at least 50 centimeters long, so that means 50 centimeters or greater, right? So it's going to be a pretty small percentage. Let's take a look at that. So we're going to do second distribution, norm CDF, and then in this case we want 50 to infinity, right? So we're going to do 50 for the lower and then infinity, which would be 1 EE 99 as positive infinity, and then our mean is going to be 41, and the sigma value is either going to be square root of 11 or we can put 3.32. Okay, you can actually type in square root of 11 there and it'll calculate it for you like in real time, but I'm just going to put 3.32 because we already know it is, and the answer is 0.0033557. Okay, and let's see what's next. The answer in the back of the book is actually 0.00333. Maybe what they did was they put square root of 11 and they got a little bit more precision out of it. So if I put square root of 11 here, then maybe I get a slightly different answer. Yeah, then I get 0.00333. Okay. So next we're going to find the probability that the eels measure between 40 and 50 centimeters long. So once again, I'm going to put the scale here on the x-axis, and I'm going to do between 40 and 50. So 40 would be about here, and 50 would be way over here, like I had before. Okay, so that's a pretty big percentage. Looks like it might be even bigger than 50%. So let's do this one. We're going to do second distribution, norm CDF, and we're going to put in 40 and 50 for my lower and my upper. And then for the mean, I'm going to put 41, and then I put square root of 11 for sigma, paste that, and I get 0.61516. 0.61516. Okay. And how many eels from a sample of 200 would you expect to measure at least 45 centimeters in length? Okay, so let me just make another drawing with a x-axis scale, and I want at least 45. 45 would be about here. 45. And at least 45, that would be bigger than 45. So that looks like, I don't know, maybe like 10% or something. So let's go ahead and, oops, second distribution. Oops, quit. Quit will get you out of anything. Second distribution, norm CDF, and we're going to put 45 centimeters as our lower, and our upper is going to be 1E99 because we're looking for infinity for upper, EE99, and then 41 and square root of 11, right? And then this will give me 0.1139. That's what I was estimating, about 10%, right? So that's about right. 0.1139. And then I'm going to multiply that times 200 eels to see how many eels from that sample of 200 would be 0.1139 fraction, okay, or 11.39%. So 200 eels. And that gives me 22.8. And then I'm going to round that to whole number of eels, which would be 23 eels. All right, last one on the page. Apples from a grower's crop were normally distributed. Normally, notice how all of these problems have the code words normally distributed in there. Remember how I said that on the IB exam, the normal distribution problem is the one problem that you're going to know which one is from that chapter because they have to use the two words normally distributed. The only way they could avoid it is maybe they could use that code. Remember the code where they have to like give you, oh, X is distributed as a normal distribution with this mu and this sigma, right? That's probably the only way they can avoid actually saying normally distributed. With a mean of 173 and a standard deviation of 34. Apples weighing less than 130 were too small to sell. Find the proportion of apples from this crop which were too small to sell. So let's make our drawing first. So 173 is the mean, standard deviation is 34 grams. Both of these are grams, so we don't need to do any conversions here. Just need to add and subtract 34 to 173. So that would be 207. That would be 173 plus 34 is 207. If I add 34 again, it would be 241, I think. And if I subtract 34 from 173, it would be 139. And if I subtract 34 again, then it would be 105, something like that, okay? And so let's see if that's good enough to mark our interval. So the interval says weighs less than 130. So 130 would be probably around here, right? And less than 130 means it would go from negative infinity to 130, right? So that's what I'm going to put in the calculator, negative infinity to 130. So second distribution, normal CDF, negative 1 and negative 1 EE99. Oops. 1 EE99. And my upper is going to be 130. And I think I'm going to get something really small, like 5% or less. And the mean is going to be 173. And the standard deviation is going to be 34. It's going to be small. Okay, it wasn't as small as I thought it was going to be, but like 10%, right? So 0.10299. Okay? Why am I giving 5 sig figs instead of 3 sig figs? Just to get in the habit of getting 5 sig figs, because later we're going to do problems where it kind of is better to keep more sig figs. The best way to do it actually is just keep all the digits on your calculator and copy and paste using your calculator. I think that's it for this page, right? That's it. So next page is 4.